My name is Ricardo Merizalde, and I'm the software development manager at backcountry.com. I currently lead the search and recommendations team. And today I'm going to be sharing a little bit of the work we've done to move away from FAST to Solr on ATG. So who we are, Backcountry is an online retailer of high-end outdoor gear. It was founded in 1996 by a former Olympic skier, Jim Holland. And we currently run 7 e-commerce sites, including Backcountry, Competitive Cyclist, and Dogfunk, and Steep and Chip within others. Since 1996, we have been running on a legacy e-commerce platform based on Perl and Postgres, and we scaled that platform to its limits until we had to make a decision to move to another platform. So in 2012, we implemented Oracle or ATG Commerce, and also, since 2008, we have been using FAST to power our search. During the last Q4, our search engine received about 1 million daily hits. Why are we changing search engines? I think it's not a secret to anyone that the roadmap for FAST has changed, and it doesn't align to many of our roadmaps. In addition, we have been using a product called Fast Impulse. I don't know how many are familiar with it, but it's an e-commerce product that sits on top of ESP. And basically, that product came to the end of its life cycle, and we have no choice. We have to move away. In addition, we have other pain points, like the index latency. For us, that's a very important thing to be updating our inventory and prices as soon as possible to provide the best user experience. The hardware footprint and the deployment of new servers is not a trivial thing. Also, we are limited. Our licenses are limited. We have a QPS limited license, and if we want to move away from that, Microsoft is telling us, well, you have to move to the new FAST, and you have to move to Windows, and that's something that is not on our plans. We don't want to do that. In addition, the support has been a high effort on our side, because the Impulse, especially, the components that live within Impulse have multiple bugs, and we have to be dealing with that. And the support response from Microsoft is not that fast. We used to get at least patches in the past, but for a while we have been running without any support because Microsoft is no longer providing patches for that product. So basically, when we run into issues, that we go to the Microsoft solution, restart the service, right? And finally, we feel FAST is not a good fit for continuous delivery. So we started searching for a new search platform about a year ago. And our goals were to have, one of our main goals was to have a low index latency. We also wanted to have a highly available cluster that was easy to scale. We wanted to be friendly with our continuous delivery initiatives. We also wanted to improve some of our user experience issues we were having, and finally, we wanted to at least maintain the same merchandising tools that ESP provides, or improve them if we could. So those are the topics that I'm going to be covering today. Some of the things that we did to approach this, to get this to implement this approach. So, open CommerceSearch. So, about towards the end of last year, we started prototyping a search solution based on Solr, and we started writing a small project that we call Open CommerceSearch, which is basically on its first iteration is going to be an integration between ATG and Solr. We have plans to actually remove many of those dependencies to make it available for other e-commerce platforms if we need to, or if people are interested in using it. It also provides a search model that I'm going to talk in the next slides, and that model provides the business tools for our merchandisers. And finally, we also provide some facilities for the developers to make their lives easier, like writing integration tests, writing automated tests, and hiding some of the complexities about Solr within an abstraction layer. So the overview of the integration. How many people in here is familiar with ATG? Probably none. Well, one, okay. So I'm gonna just give a very brief introduction to ATG. So on the very left, we have the ATG Business Control Center. That's the application where our business users or our merchandisers log in to manage their assets or artifacts. And those artifacts can be promotions, it can be taxonomy, assigning products to taxonomy. In some implementations of ATG, they actually manage the product and SKU content in this application. That's not our case. And now with Open CommerceSearch, this is where the merchandisers are gonna be managing the search assets, which include, for example, facets or blocks and boosts, etc. So ATG implements its own versioning control. And basically, when they log into the Business Control Center, the first thing they need to do is create a project. And within that project, the merchandisers will add new assets or modify existing assets. And once they're happy with their changes, they can go ahead and deploy their project into an ATG preview instance, which basically is just a copy of a productions instance. It's a simple, a fully functional copy of the production site where they can preview the changes they have done. And if they're happy with it, they can approve those contents and request to deploy those changes into the productions instances. That is actually a cluster with multiple servers. And we normally do those pushes to production overnight. So that happens once a day, once all the merchandiser assets have been tested and approved in the preview instance. If the changes they are doing require a change in Solr, for example, let's say they are adding a new synonym or adding a new synonym list, once the project is deployed to the different environments, we go ahead and we update the configuration in Zookeeper, and we reload the course so the configuration takes effect. I just want to mention that we use the same infrastructure, search infrastructure for both environments, but each of the environments run their own cores. They have their own set of cores. So people can do changes in preview without affecting what the customers are seeing during the day. So the search model provides it's that interface that allows the merchandisers to modify and merchandise the products on the site. Right now we support facets. We support redirects, which basically a user can enter a query term and they can redirect the user to a page. Like, for example, gift certificate, instead of showing a page with a single result, they will go directly to the product detail page. We also support synonyms, which that's a little tricky, because if you leave that very open to the merchandisers, they can end up actually hurting the search results. So you need to be very careful about that one. It's very useful to let them use the tool, but I think there has to be some mechanism to govern the synonyms. Boost and blocks, it's basically that's the same concept that fast ESP and fast impulse support. Basically, you can select products and put it on the top 10 positions in fast, or you can actually block a product. Like, for example, if somebody searches for gloves, and then the first product is a body glove shirt, you don't want that there, you can block it. In Open CommerceSearch, we don't have a limit on how many things you want to do, but those types of rules, we are just supporting them to give parity with what the merchandisers have right now. We implemented a new rule called ranking rule, which I'm going to explain in the upcoming slides. So once you create all these facets, you need to find a way to link those facets or those artifacts to a page, right? So that's the way we did that is we built the rule engine, and the rule engine itself, it's based on Solr. So it has its own index. The index is very small. It's very fast to actually query and see what the rules are for the page the user is viewing. But it requires an extra call, an extra search, because you first need to search for the rules. And then once you have the rules that apply to the search page, do a search for the products with those rules. it's very easy to actually, the rules are so small, they normally, they can be within a few hundreds to a few thousand rules, so you can easily catch those on the client and avoid the two calls to the search engine. So when you go to the BCC and you create a new project, this is the first screen that users will see. Here at the bottom, you can see the search model. That's our custom model. So if you drill down to that, you'll see first 3 options. You can create rules, you can create facets, or you can create synonyms. If you drill down on rules, you're going to see 4 types of rules: ranking rules, facet rules, boost and blocks, and redirect rules. All of these rules have these common properties. The first one, and probably the most important one, is the context. So when you create, like for example, when you create a facet, you can target that facet for a given search page or for a given category page. In our case, we more than 50% of the pages on our sites are powered by the search engine, so it's not only search. So every time you visit like a category or browse the catalog or go to a brand page, all the data that shows up in that page is being powered by the search engine. So we can actually target the artifacts to the different pages or to both of them. For example, global facets like the brand facet and the color facet, that's you probably want to apply across all the site. If you choose to target a search page, you can select, you have to select a query that you want to target. And we support 2 different syntaxes. You can do the first one is a partial match, and the second one is an exact match. So you just put the query within brackets, and in order for the rule to match, it has to match the very exact query that a user is entering. To be honest, that's the most. So far, that's the most the approach that people use the most, because the partial match can be too open. The query engine goes through the same process as the search, so it will do stemming, it will do synonyms. So you might end up creating a rule that applies too wide on the site. So that's a rule that we need to use carefully, and we don't use that often. Also, ATG, since version 10, supports multi-sites, and that's very important for us. In our case, we run multiple sites on the same e-commerce platform. So you can target your rules to a specific site. You can also target your rules to a catalog within the site. So in our case, we might have a catalog for the retail inventory and maybe a catalog for the closeout inventory, and maybe the facet rules can be different for each of them. And finally, we have the category. The category context is what that you can actually apply rules specific to a category, and we do that a lot, specifically for boosting and for what we call local facets, which we facet on attributes that are specific to certain product categories. And finally, we have the lifetime of the rule. Especially with ranking, people tend to create rules, boosting rules, and they forget about them over time, and then a year after, you wonder why something is not working as expected. So we really foster our merchandisers to use these rules, so they can go back and then clean up everything that has come to its end of date. Now, those are the custom properties. Each property has its own custom fields. In this case, we have in the upper, we have the facet rule, where you can actually attach multiple rules at the same time to a page, and you can select the order that you want the facets to display. In the second way, it's a simpler property. You just specify the URL you want to redirect the customer to. I'm gonna talk a little bit more about the ranking rules, because this has proven to be very helpful for our business. So the ranking rule is basically a mechanism to boost or demote chunks of products instead of individual products. So customers are really our customers, not our internal customers, the merchandisers. They're very happy with this type of rule because it requires less manual boosting. However, that's not our ideal state. We don't want to be doing too much manual boosting. We want to come to a point where we can actually automate the ranking of our products, and that's our next step on this platform, is to actually use multiple data points like clicks, revenue, orders, etc. All the data that we have on our data warehouse, and use that to as an input for our ranking algorithm. And to implement these ranking rules, we leverage a lot of the out-of-the-box boost functions that Solr provides. So this is an example. When you create a ranking rule, you have two options. At the top, you can either boost by a boost factor or an attribute, and an attribute can be a field on an index, like the stars of a product. If you choose the boost factor, you have to choose a strength of the boost, which can range from a very strong demo to a strong boost. And finally, you have the conditions that you want to apply your boost to. So in this case, the interface is really rough on the edges. It's not a very user-friendly, but it does the work. So basically, they can create complex expressions here. And in this example, what I'm saying is that I want to boost all the bikes and frames that are from the brand Pinarello and that are not on sale. So these type of rules are really helpful when you have broad terms. People are searching for broad terms, but their intention is probably very specific. Like, for example, bike. If you search for bike, these were the results we were getting in Solr before having the ranking rule. And the content is not ideal. The bike shows up in the title, in the description, everywhere. So it's really hard for the default ranking algorithm to know what the user is looking for. So we created a very simple ranking rule, where we are just boosting a category. And now this is what the user will get if they search for bike. And then you can mix rules. So if you want to, boost the bikes differently within that block, you can also do that. But the user experience is way better, and we're seeing a lot of improvements in our revenue on the pages that we are doing this. We also extended the ATG category taxonomy to provide something that we call rule-based categories. So people can, instead of having merchandisers assign products to categories, they can actually select the products that are going to be shown on a category page based on the same expressions. So in this case, for example, we receive new merchandise in new board shorts. They can go ahead and create a promotion page or a landing page and select all the board shorts of a specific brands that are not on sale. And this is very useful, as I mentioned, to create promotion landing pages or keyword landing pages that provide real SEO value for the company. So in this case, this is how the page will look like after applying a rule-based category page. To summarize the migration of our assets, when we were moving from Impulse to ATG or to Solr, we were able to import all the redirects as exact matches. Solr Impulse supports like partial matches for redirects. In our case, we didn't need that. Synonyms, that was a pain point for our merchandisers, because synonyms work very differently in Fast Impulse. Basically, Fast Impulse does query expansion, and it supports synonyms with multiple keywords or multiple terms, and that's something that it's not really supported in Solr because there's a limitation in the Lucene parser. So, but there's a workaround. There's a synonym expanding Edis Max parser written by Nolan Lawson, and we are using it. And so far, it's proven to be very helpful, and we can tackle like 90% of the use cases that our merchandisers have. Also, synonyms were a black box for our merchandisers. With Solr, they can use the analysis tool, and it really helps. At the beginning, it was a bit difficult for them to understand it, but once we educate them, they actually use that tool widely to figure out what's going on if they have problems with results or synonyms. Okay, the index latency. So if you are using Fast Impulse, you are very limited in the way you can actually import data into the index. You basically can only use XML files and a tool they provide called XLT. So in a high overview of our process, we have to generate XML files. We need to CSCP those files into the fast servers. Then we have to write a custom cron job to use that tool to to put those changes into a SQL schema. And then we use the connector from Fast called JDBC connector, which is constantly monitoring the database for changes. And then once it finds changes, it's going to put them on the impulse document pipeline and finally into the index. So there are multiple points of failure here, and they do fail. So we need to be spending time figuring out where the indexing process is failing, and it takes several hours for this process to complete, especially when you are doing a full fit. It can take like really several hours. And our pipeline, our document processing is really simple. We're not doing anything really complex there, but still it's slow. It's not ideal for us. So what we did with Solr is we are leveraging the near real time. So instead of having these batches, we use the API calls over HTTP, and so every time a change comes into the system, we can do incremental changes and send it right away. And we have different SLAs for the different change types. So for example, the price and inventory, they are done as soon as possible on the production environment. If somebody's changing the content or the taxonomy of a product, it only changes overnight. But in the preview environment is the other way around, because you want your users to be seeing the content and taxonomy changes as soon as possible so they can test them before they push them to production. And in that preview environment, price and inventory is not that important, so we only update price and inventory overnight on the preview instance. We don't do any commits from our code. We configure the Solr to do auto soft commits and hard commits. Right now, I think we're doing like soft commits every 5 seconds and hard commits every 10 minutes. And so far, the performance is fine. Our catalog is not huge. And we have been monitoring the caches, and the performance is very acceptable. In fact, it's better from what we're getting currently from Fast Impulse. So far, we're happy with it. Maybe in the future, if the catalog keeps growing, we might have to change those settings. But so far, it's working for us. So this is very similar to the first diagram I showed about the integration. However, the big difference here is that the product data, the master of record for the product data is not in the ATG BCC, but instead it's still on our backend systems. So we have multiple systems and multiple teams creating data for the products. We have SKU makers, we have content management, we have the photo studio uploading images, and we have the inventory management, the system of records also on the backend where on our legacy platform. So there's a process crunching all those changes during the day, and it's going to publish when it finds a change, it's going to publish it through a JMS queue, and then we have subscribers on the different environments listening for those changes. So for example, in production, when there's a price or inventory change in the queue, it's going to be applied right away and sent to Solr. In the preview instance, the inventory and the price, it's going to be ignored during the day, and it's going to wait until night to process all the query, update all the inventory and prices. If the product change is a content or it's a taxonomy change within the BCC, if the changes are going to be applied to Solr right away in the preview instance, but it's going to go overnight to the production instances. Continuous delivery. So for us, it was really hard to do integration testing with Fast, and the automated tests were very flaky. There was a lot of data dependencies. We were running a test, and it was changing the index, so the next test that was running was going to fail because the data was no longer there. And there was no way to actually create application states, because those same environments, like the FQA, functional environments that we were using, were also being used by manual QA to test the site. And there was always conflict, so we had to be fixing data every time we were running the tests. So to fix that, at least for search, we are leveraging the embedded Solr server. So we run really small indexes on RAM, and eventually each test, integration test can have its own index. And to load the data into those cores, we use the Solr XML syntax. So we have each test can have its own test data. For the automated test, we use TestNG and Selenium. So let's see a couple examples here. So for example, for an integration test, when the suite starts running with the tests, we're going to create a shared core, and we're going to bootstrap the data on that core. And if you, for example, if you create a test and you just tag the test with the annotation search test, it's going to use that core. And that core is going to be read-only to ensure that we have data independence, so the test cannot change the data in that core. However, if you need if you need a specific data for your test, you can always use the search test tag and indicate that you need a new core, and that's the data that you want for your core. So what it's going to do is it's going to clone the shared core, and it's going to apply those changes while the test is running. And it's really fast. I mean, if you keep it small, the data for your test, our test cases run like within less than a minute, and it's really effective for us so far. So in this case of the integration test, the test code and the server, the Solr servers, are running within the same process. Now for the automated test, this is a bit different. The syntax is going to be very similar. So we use TestNG. This is no longer the JUnit. So in this case, each test is going to open a browser and it's going to run, a specific. It's going to go to a specific page and maybe run a query that is specifying this test data. But we can also tell we can also test the test that this is a search test. So what this is going to happen is when the automated test suite starts running, it actually is going to contact the application server, and it's going to tell them, hey, I want to run a set of tests, and it's going to send the bootstrap data, and it's going to create a core within the application server, not the test code, or not the JVM where the test is running. So when that test hits the application server, it's actually hitting the test core and not the Solr server that has been configured for that environment. And the same way you can specify data for a specific test, you can do the same here. And what's going to happen is when this test runs, it's going to send the data over HTTP before actually running or hitting the site for the automated test. On continuous delivery, the deployments are way simpler for us. Normally with Fast, if we wanted to create a new testing environment, or we wanted to add more search nodes, it was not a trivial thing to do that. So with Solr, that's something that we really love and the DevOps teams really love. So our workflow goes like this. We have configuration files and source code in Git. Then we have Jenkins monitoring those repositories, and when it finds a change, it's gonna generate a new RPM. We basically deploy Solr through our own RPMs. And Jenkins, for example, in the case of an FQA environment, can invoke Rundeck. And Rundeck is going to apply those RPMs automatically to Solr or Zookeeper instances. In the case of production, we don't want to do that. That's something that we have a release engineer do, but it's only at one click, as I'm going to show later. And we also have like a custom Zookeeper command line interface, which basically it's going to get the default configuration files in the Git repository. Then it's going to download the configurations that the business are managing in Zookeeper or in the BCC. It's going to download them from Zookeeper. And then also it's going to grab like a specific production configurations that we have for our deployments, and it's going to mix those, and then it's going to update Zookeeper again with all the different changes merged together. So if we look at the Rundeck interface, we can update the different RPMs by clicking play. We can deploy new configuration to Zookeeper by clicking just one button, or we can actually reload all the cores within our Solr service by just clicking one button. And these jobs can also be invoked from Jenkins, which is really, really convenient. Okay, so finally, On the user experience side, one of the main things we wanted to fix was the inconsistency within our search results and the product detail page. So the problem we were having and customers were complaining a lot was that, for example, they were searching for an orange XXL jacket, and they will find something in the result pages. But when they click on the page, the product was not available in the specific size and color. It was either available in orange or in the size. So what we did is we denormalized the data, and instead of indexing compounded documents, we are indexing SKUs, and we are grouping by product ID. So let me show you an example. So this is a search for orange XXL jacket in fast. If you click on the first result, you'll go to the product detail page, and you will notice that, okay, we have the orange jacket, but I'm sorry, we don't have it in XXL. And this is really not a good user experience for our customers. So in Solr, sorry, now if you do the same query, this is the results. The first thing you can notice is that it is very likely that you will get the color or the thumbnail for the color you're looking for. And if I click on the first product in this case, it's actually available in orange and extra large. So grouping is awesome. We love it. Our business love it, but it's CPU intensive. If you have a very large catalog, you really have to think about using the grouping feature. Keep a really close eye on the query response times. Because if you need to group or facet on groups instead of documents, your CPU consumption is really going to go high. So for example, pay attention for partial matches searches. In our case, the way we deal with those is that we do an exact match. And if we find documents, we present those to the customers. If there's no results for their match, we're going to do a partial match. And that was working fine in fast, but in Solr, we were getting very terrible responses because a query that didn't match exactly may end up returning 70% of the catalog. Like for example, if you search for maybe, I don't know, red something, and that something is not in the results, then you get all the red stuff you get on the index. So I highly recommend that you pay attention to that and use the minimum should match parameter. So those broad searches will be more narrow, and you will get better performance. And finally, keep an eye on the facets. In our special case, we love to add facets every day, or the business likes to do it. But the reality is that if you check the omniture and the statistics, is people don't click on most of those facets. And facets, I feel, is the more expensive operation when you're doing grouping. So keep an eye on those if you want to use grouping, and just use the ones that you really need. And I think that's all I have to share with you guys today. I think we have a few minutes for questions, maybe. That's a really good question. Our index is not that large at this point. We have like around I think it's around 250,000 SKUs that we are indexing. We have millions of SKUs, but we don't index them all. So it's around that number. And I think that total number of products is around 40,000 products. So that's the ratio between SKUs and products that we have in backcountry. Okay, thank you.